In this video, we shall consider another example where a goodness of fit test will be very appropriate. So this concerns a scenario at Central University Food Service. One of the challenges in managing a food service on a college campus is predicting how many students will show up for meals. Central University operates three different food service facilities on campus. One of these is the Riverview Cafe on campus, which is open 5 days a week, Monday through Friday, for breakfast, lunch, and dinner. The manager has been ordering food products for the three meals under the assumption that there is no difference in demand for various food products by day of the week. This is the null hypothesis. The assumption, or the status quo. So recently, the managers received complaints that the cafe frequently runs out of pie. As a first step in analyzing this issue, the manager decides to conduct a test to determine if student demand for pie is uniformly distributed across the 5 days of the week or whether some other demand distribution applies. So the manager collects the data over the course of what? A representative 4 week period. And the following data represent the number of pies used on each day of the week. Students took a total of 2,120 pieces of pie over the test period, and under the hypothesis of a uniform distribution, 20% of this total, which is 424, should have been what selected on each day of the week if the assumption highlighted here is true. What is the assumption? It is the assumption that there is no difference in demand for various food products by day of the week. Thus, the expected number of pieces, if the assumption is true, each day is 424. And that would be the number that will be going to our expected cell frequency. So, in this example, if we're going to conduct a chi-square goodness of fit test, we need to set up the null hypothesis and the alternative. The null hypothesis is the hypothesis that reflects the status quo or the initial claim of no difference, and that is going to be stated as the distribution of pi demand is uniform across the different days of the week, Mondays to Friday. Whereas the alternative would be the opposite, that the distribution of the pi demand is not uniform. As usual, we're going to look at the assumptions that underpin the goodness of fit test, not ANOVA. That was a typo there. Goodness of fit test. Okay, the same thing here. And in this case, you have independence and what? Sample size or distribution. In the case of sample size distribution, we expect that what value is imputed or that we have for each expected value under the assumption that the null hypothesis is true should be equal to 5 or more than 5. And that appears to be the case because we have 424, which is exceedingly greater than 5. All right, so with that said, let us go on to the mechanics. In this case, I would like to take the data set to StatCrunch. So here we go. All right, let's see. So in StatCrunch, let's see what we have here. Good. And in StatCrunch, I have the data values here. So for pieces of pi, 358 to 380, here it is. And for the expected value for each of the days of the week, under the assumption that the null hypothesis is true, is 424, and that is 2,120. The sum of all of the pieces of pie divided by 5, shared uniformly across them, across each of the days. So you have 424. So in this example, I wanted to show you if you have the expected values already given, and versus what? The PCs. How do you conduct your goodness of fit test in StatCrunch? Go to statistics, go to goodness of fit, go to chi-square test, and for the observed, we want the raw values that were observed from those in the sample, which is saved under PCs. So I'll select that. Then for expected, this time I can also use all cells in equal proportion, but I'm going to say I've keyed in all my expected values of 4 to 124. So I'm saving that under expected right here. And I would like to see my expected values and conduct my goodness of fit test. So this output shows that we have a degree of freedom of 4. That should be expected. That will be number of categories or bins 1, 2, 3, 4, 5 minus 1, and that will be 4. And then we have the chi-square value, which is 72.231132, and which leads to a p-value. How do we get the p-value? Using the chi-square distribution. If we go to statistics, go to calculators, go to chi-square calculator, I'm going to key in the degree of freedom, which is 4, and I have grabbed the chi-square value, so I want that to be in the upper tail of the chi-square distribution. Okay, all right, so you have 2 there, and let me grab this and compute. You will notice that this is a very, very small value. This is 0.0000, about 15 zeros before 766605. So that is why the p-value, this is a number that is highly lesser than the p-value. So taking all of that value, all of those statistics and the test statistics to our workbench, I can use the p-value to compute the p-value, the chi-square test statistic value to compute the p-value, which I can pull into drawing a conclusion. And my conclusion will be as follows: that because the p-value is less than 0.0001, which is also lesser than the level of significance. Were we given? No. So in that case, we assume 5% alpha, 5%, the default value. That means we reject the null hypothesis. We reject the null hypothesis in favor of concluding on the alternative, which is our research hypothesis, which means that there is sufficient evidence. There is sufficient evidence in the sample data, to state what is contained in the alternative hypothesis, that the distribution of pi demand is not uniform. That the distribution of pi demand is not uniform across the days of the week. So some days appear to have a higher demand for demand than others.